All right, so when we are looking at logarithms, we have some weird properties to go by. So one of the properties is if the argument is joined by multiplication, I can separate that out into two separate logs that are joined by addition. So first of all, we're going to highlight the two different factors. So I have a 3 times an x. So I'm going to have two separate logarithms. So this is going to become log base 5 of 3 and log base 5 of x. So I'll have two separate logarithms, but if it's multiplication on the inside, it's going to be addition on the outside. So I have now expanded this logarithm. Okay, so we're going to try it again. How many factors do I have? I have a 30 times an x times a 3x plus 4. Okay, so I've got three factors this time. So if it's connected by multiplication on the inside, I can connect it with addition on the outside. So I'm going to get three separate logs. So I've got log base 5 of 30, log base 5 of x, and log base 5 of 3x plus 4. So if it's multiplication on the inside, it's going to be addition on the outside. So I have now taken a single log and expanded it into multiple logs. And now I'm going to go backwards. Okay, I now have two separate logs joined by addition on the outside. So I am going to condense that into a single log. If it's addition on the outside, it will be multiplication on the inside. So I have log base b of 7 times y. Okay, so two separate logs. Addition on the outside becomes multiplication on the inside. So take your arguments and join them with multiplication. So now I have, let's review real quick. My base is not written. So what base am I working in? This is base 10. And I read this as the common log. So again, I've got an argument of 15, and I've got an argument of 2 plus 4z. So I've got two separate logs joined by addition. So I'm going to combine that or condense that into the common log, base 10, of 15 times 2 plus 4z. And now if you wanted to simplify that a little bit further, we can go ahead and distribute that 15. So that would give me log base 10, or the common log, of 30 plus 60z. Okay? So now we're going to move on to quotients. This was product. So I had multiplication on the inside changes to addition on the outside. Addition on the outside changes to multiplication on the inside. So now we're going to move on to quotients. So our rule is going to be, if it is multiplication on the inside, it's addition on the outside. Well, guess what? If it's division on the inside, that means it'll be subtraction on the outside. So for this one, I've got the common log of 7 divided by b. So I'm going to have two separate logs because I've got 7 divided by b. Okay, so that's going to turn into the common log of 7 minus the common log of b. That's hard to see. Okay, the common log of 7 minus the common log of b. So I have taken something that was condensed and I have expanded. Okay, this one has got a whole lot of stuff going on. Okay, so I have, let's see if we can do this. I've got a 15. I've got an x. I've got an x minus 1. I've got a 3x plus 4. And I have a 2 minus x. Okay, so I have 5 things going on. 1, 2, 3, 4, 5. So if it is multiplication, and I'm going to actually broaden this a little bit. If it's in the numerator, I'm going to lead off positive. So what does that mean? Look up here. I had a 3x. This led off positive. There's a positive 1 there. And this led off positive. Okay? Now look what happened when I was in my denominator. The 7 was in the numerator. He led off with a positive 1. The b was in the denominator. That logarithm led off with a negative. Okay? So what this is going to look like is I'm going to have 1, 2, 3, 4, 5 separate logs in base 2. So I've got log base 2. I'm going to write kind of small. So log base 2 of 15. That's my first factor. I'm still in the numerator, so do addition. Log base 2 of x. I'm still in the numerator, so do addition. Log base 2 of x minus 1. There's a 2 right there. Okay. Now I drop to the denominator, so use subtraction. So minus, so this is a division problem now. Log base 2 of 3x plus 4 minus, and then I've got log base 2 of 2 minus x that I ran out of room for. Okay, so I've got 1, 2, 3, 4, 5 logarithms. The ones in the numerator let off with positive, positive, positive. Okay, the ones in the denominator let off negative and negative. All right, so let's look at this one. We're going to condense. I've got subtraction on the outside, which means it's going to be division on the inside. So I've got a W and I've got a 5. So this leads off positive. He's in the numerator. This leads off negative. He's in the denominator. So I will have a single log base 9 of W over 5. And then the last one that I've got is subtraction on the outside with 2 separate logarithms. So I've got this argument, and then I've got this argument. I forgot to highlight that other one. So this was subtraction, this is subtraction. What's your base? If your base isn't written, it's either 10 or e. This is not a common log, this is a natural log, so this is base e. So I've got 2 logs joined by subtraction. This one's leading off positive. So I'll have the natural log of v plus 1 over, this one leads off negative, so drop down and do x minus 9. Okay, so moving on, we have, let's do some power rules. Okay, if I have an exponent and I am expanding, then exponents are a no-no. If I am expanding, exponents are a no-no. And what we can do is drop this exponent out front as a coefficient. Okay, so this is going to become log base 2 of x, but this 5 is going to drop out front as a coefficient. So I have expanded this. When you expand, you will not see any exponents. Okay, so I need to expand this one. Okay, so this gives me, I need a couple of steps here. I'm going to bring this x squared to the top with a negative x. Actually, let's not do that. Let's do this. I've got the natural log of 1 minus the natural log of x squared. Well, we learned before that if your argument is 1, this goes to 0. So now I have 0 minus, and I can bring this 2 down as an exponent. So I have 2 times the natural log of x. Okay, so 0 minus, I don't need that. So my answer is a negative 2 natural log of x. Okay, I could have brought that negative, I could have brought this up as a negative exponent to start with. And then I could have just dropped my negative 2 out front. So I would have had a negative 2 natural log of x, and I would have gotten the same thing. Okay, so now you see, again, why we're using negative exponents. So I've expanded those two. If I'm expanding, exponents are a no-no. They are off limits. If I'm condensing, I need to kick up my coefficient. So condensing, notice the CK sound. If I'm condensing, you kick up your coefficient. So that 7 is going to kick up. And this will now be log base 4 of y to the 7th. Okay? So I am condensing here. I'm going to kick up my coefficient. So this becomes the natural log of x to the 1/2. And remember, just for kicks, that is the same thing as the square root of x. So that's an x to the 1st, but you're taking a square root. Okay? So let's get a little bit more exciting, and let's do a few things. So I notice that I can rewrite this using a rational exponent. So I'm going to expand. So I have log base 2 of x to the 1/3. But if I'm expanding, then exponents are a no-no. So I need to drop that 1/3 out front as a coefficient. So I get 1/3 log base 2 of x. Good heavens, where'd the 2 come from? Of x. I'm just randomly changing things just so I can confuse you. Make that go away. Go away. Okay, so what I have is, this is an x. Okay, so I drop my 1/3 out front. This one, I got a lot of crap going on. Okay, so let's look, because we're going to morph a whole bunch of stuff together. I've got multiplication going on, and I've got division going on. So I'm going to do this in 2 steps. We're going to go ahead and expand everything, and then we're going to take care of the exponents. So the first thing I do is I've got 3 different things joined by multiplication and addition and division. And so I'm going to have 3 separate logarithms. What is your base? It is not written. So it's either 10 or e. This is the natural log. It is base e. So I've got the natural log of x squared. I've got the natural log of y to the 3rd. And I've got the natural log of z squared. So this is in the numerator. He'll lead off positive. This is in the numerator. He will lead off positive. This is in the denominator. He will lead off negative. Okay? So numerator, numerator, drop it for a denominator. Now, since I am expanding, exponents are a no-no. So each one of those exponents is going to drop out front. So I will now have 2 times the natural log of x plus 3 times the natural log of y minus 2 times the natural log of z. And now I've expanded him. So let's look at this one. I've got log base 4 of x plus y. If it's addition on the inside, I can't do anything. Okay, I'm stuck. There's nothing I can factor out. I cannot change this into a multiplication problem or a division problem through factoring. So I'm done. I cannot condense this. I cannot expand it. So he is done. Complete. Okay? There is no property that I can use to fix that.